What we'll be doing here is looking over the textbook, your online textbook for Math 1108. And we'll be putting this up to our YouTube site, and hopefully it'll be useful for you. So we'll start off with Algebra and Equations, Chapter 1. And in Chapter 1, we'll be going over real numbers, polynomials, factoring, rational expressions, exponents and radicals, first-degree equations, and then quadratic equations. So in a sense, in this one chapter, we'll be doing a real quick review of the basic skills of algebra that you need to bring into your next few chapters. Now, as we look at our first subtopic in Chapter 1, we're going to look at what is called real numbers. It says only real numbers will be used in this book. And what are real numbers? Well, to give you a little background, if we have a number line, and on this number line we place a 0 in the middle of it, and we look at different sets of numbers. The first set we look at is natural or counting numbers, and this set would be like 1, 2, 3, 4, and then this ellipsis indicates the pattern continues. We sometimes write that using a brace here, and then this is a method we call roster notation. And if we plot this on the number line, we have 1, 2, 3. Oh, my numbers aren't coming out too well. And then 4, and then 5. Now, to indicate that this pattern continues, I just put an arrow there. And to actually graph them, I put a little dot on the values here. And this arrow indicates the ellipsis that it's continuing. So, natural numbers, one of our first sets of real numbers, 1, 2, 3, 4, and then an ellipsis indicating the pattern continues. And then getting to our next set of numbers, which are called whole numbers. And the only difference in this set is we've added a 0. And then putting it in roster notation, and then graphing it. Now I'll need to go to the next page, so I'll be erasing this, but they do have a line that comes up here. So our next group of numbers would be set is integers, and you'll notice there are our whole numbers 0, 1, 2, 3, but now we're going to the other side of 0, to the left of 0, and we get opposites of our whole numbers here, and our counting numbers, opposites, that if we add a -1 and a 1 together, it makes a 0. A 2 and a -2 makes a 0. Well, so whole numbers and their opposites make up a set of numbers that are called integers. And on the number line, we will see this. They're going to show us some of this in a little while. Then the next major set is rational numbers. Now, I often describe this for students by saying if you take, and we'll just take a piece of the number line here. So there's 0, there's 1, there's 2. And are there numbers between 0 and 1? And the answer is yes. Right there is a 1/2. Now, when we convert 1/2 to a decimal, we get 0.5. And are there other numbers? Well, let's just change the color and say yes, right there. There is 1/3. And when we convert that to its decimal, it's 0.3, and the 3's repeat. So we often put a repeating bar over the 3. Now notice here we had a fraction that terminated, stopped at 5. Here we have a fraction that repeats with a 3. But over here there's another number right about there, which is the square root of 2. And my number's not coming out too well. All right, the square root of 2. Now the square root of 2, if we converted that to a decimal, it's 1.414, and then it kind of goes through a series of numbers that doesn't terminate, nor does it have a repeating pattern. It just bounces around and never ends. Well, this type of number makes up the next set, and that is irrational numbers. Now, rational numbers then, we said, are all of the numbers we've talked about, the counting numbers, the whole numbers, the integers, these fractions between the integers, as long as they terminated or had a repeating pattern. All these others are called irrational numbers. Now, all of these numbers on the number line are real numbers. So that would be your large umbrella for all of these other numbers. So in your studies, you'll be challenged to identify a number as to which category it belongs to. And through practice, you will hopefully master that. So let's go on. And now this is the pattern they will give us throughout this, is to give us some kind of examples. And of course, as you read your textbook, you could read these as well. Here they're saying the number 6. The number 6 is a natural number. It's a whole number. It's an integer. And it's a rational number. And, of course, it's a real number. Now for letter B, here we have a fraction whose equivalence, if you're familiar with that, is 0.75, and it terminates. So this is a rational number, and it's real. Remember, every number we're going to deal with is going to be a real number. In letter C, another irrational number is pi. So this is 3 times pi. So this is not a rational number. It is irrational and real. And they give you some material that we've already mentioned. Now we're going to look at some properties of real numbers. And again, this is background. We don't use it a lot, but this sort of gives the things we do in algebra a legitimacy. That is, it's okay to do it because we have a property that says it is true. And some of these just make common sense anyway. So when we look at A plus B equals B plus A, we're just switching around the order. And we're saying that is true, that these are equal. And if we say we're going to multiply A times B, that's the same as saying you're going to multiply B times A. We're just switching the order. Well, this is referred to as the commutative property, that we can switch the order in addition like this, and there's no problem. Now, another famous one is you have the letters A, B, and C, and it's plus A, B, and C. The order is exactly the same, but we are grouping them differently. Here, we're grouping the A and the B, and here we're grouping the B and the C. Now, grouping indicates that we're going to do this first, then add the C. Here we're going to group these or add these first, then add the A. And we're saying that is completely legal and legitimate. And this type of thing is referred to as the associative property, how you are associating or grouping something. The order is the same, you're just grouping them differently. And this applies to multiplication as well. Here we're multiplying the AB first, and then the C. Here we're multiplying the BC first, then the A. Going on, we have some additional properties. The identity property. Here we're saying we could add 0 to any value, and it's still just the original value. There is no change. And of course, we could do it in any order. But adding 0, whether we add it later or in the beginning, there is no change. This is the identity property of addition. Now, we also have this in multiplication, that if we take 1, we can multiply anything by 1, and it doesn't change its value. We're going to use that a lot when we do fractions and getting equivalent fractions. We're going to multiply those fractions by a 1, and it's not going to change its value. It's going to look different, but it's still equivalent. Okay, then we have what is called the inverse properties, where if we have a value, A, and we add its opposite, that is a negative A, the sum of this is 0. That's often referred to as the additive inverse. and it works in the commutative sense as well. Now we have another which is called a multiplicative inverse. If we have A and we want to multiply it by something, so the result is a 1, that is its multiplicative inverse. Another word we use for this sometimes is the reciprocal. Now every number is over 1. We just don't write it. So the reciprocal, or the multiplicative inverse of something, is just to take this and flip it. So the numerator becomes the denominator, and the denominator becomes the numerator. Now notice when you multiply these together, these will cancel out. A divided by A is 1, so we get 1. Now another very famous property is the distributive property, where we have, let's say, in parentheses, B plus C, and we are asked to distribute this A. So we get rid of the parentheses. So we go A times B gives us AB. A times C gives us AC. Now we can also do it this way as well, and it becomes the same thing. B times A, AB, C times A, CA. Now, one that they're not showing at this point is, what's the opposite of doing this? The opposite of the distributive property is to take the A out of each of these terms. We call that factoring. And we'll be doing that later too. The reverse of the distributive property is to factor. And you factor out the common A. Now they're going to give you some examples. They are in your textbook. And I'm not going to do every one, otherwise the tape would be too long, but you could look these over. And again, the example is presented and the answer follows. Okay, let's go on to our next little subsection, which is called order of operations. In this, we get the acronym please, excuse, my dear Aunt Sally, which pretty much is a hint at what is the order of operations, where P stands for parentheses, E stands for exponents. So you do whatever is in the parentheses or grouping symbols first, then the exponents. These are sort of done first. And then you're going to do multiplication, division. Now, if division is first, you do division first as you go from left to right. And these can be reversed. And then again, lastly, you're going to do addition, subtraction. Again, from left to right. So they're going to give you some examples here. Let's go up and see one here. And they have it worked out for you. But let's take a look at it. So here we have brackets. This is a grouping symbol. Here we have brackets internally. Here are these. And parentheses there also. Okay, so the thing is you go from the innermost and then work out. So right here within this parenthesis, this is going to be a 5. And we're going to do this multiplication. This is going to be an 18. And we can see it right here. They have a 5. And then now we have 5 minus 7, which will give us a 2. And there's a 5 still. But we're working inside the grouping symbols. Here this was an 18 minus 3, which is a 5. So now when you get it down to this stage, it's not too bad. So this is a negative 10, this is a positive 10, and then this is a 0. So for something like this, where there's a plus and a times, we do the times first. And they're just checking you out here. You don't do the addition first. You would do the times first. So often they do put, for clarification, parentheses in there. Okay. And in your book they give you a little summary. And some of the examples now you'll get are challenging, but you look at what they give you in your textbook, and in your tutorial bars, if you have a problem, they will give you an example to work through to help hone your skills at mastery. Again, if I go through each of these, it would make the tape too long. We just want to expose you to what it's about. So use order of operations to evaluate. And here you're going to do substitution. You're going to say the x, wherever it is, in your example will be replaced by a negative 2. And the y by a 5, and the z by a negative 3. So again, careful use of parentheses and then following the rules of order of operations. And here they're asking you to use a calculator to evaluate this. In most cases you would be using a calculator. And the key is this division bar here is also a grouping symbol. You do everything on the top, get a final value. Everything on the bottom, get a final value, and then you do your division. And it's good to practice to see if in fact you're getting correct answers. Now another operation that we do is called square roots. Now there are two numbers whose square is 16. Namely 4, if you square it, is 16. And then parentheses around the negative 4. Negative 4 times negative 4 is also 16. The positive one, 4, is called the square root of 16. Similarly, the square root of a non-negative number d is defined to be the non-negative number whose square is d. We often refer to the one where it's the non-negative value as the principal square root. But keep in mind that there are two that could give you the value, and they will give you direction as to what they want you to do. Now there's one little tricky thing here that I don't see it right away. Let me just give you some background on it. If you say -4, the quantity squared, that's 16. But if they say -4 squared, now here we're looking at what is the base of that exponent. Here the base, because of the parentheses, is a -4. Here, because there is no parenthesis, the base is only the 4. So when you square the 4, you get 16, and then you apply this negative sign. So a little caution here, kind of tricky. All right, let's go on. Now when you use your calculator to take the square root of 40, remember that's an irrational number and it goes on and on and on. So usually it'll stop. There's no more places to put values. See, there's no repeating pattern, and it doesn't really terminate. So they'll ask you to round off usually to 3 decimal places. So we go to the 4th decimal place, which is a 5. We drop all of these, and we add 1 to the 4. So that's rounding off to 3 decimal places. And they give you a few more examples. So we did this earlier in our lesson, but let's look at it again. So we said if we put a dot on 1, 2, 3, and 4, these would be our natural or counting numbers. If we added the 0, that would be our whole numbers. And then if we added opposites to it, these would then be the integers. And then we said between the integers were rational numbers that are fractions who, when we convert it to decimal, if it terminates or repeats a pattern, they are the rational numbers. Now remember, all these others, the whole numbers, the natural numbers, the integers, they're all rational numbers too. But now we're introducing the fractions. But then there's a special set of numbers, like the square root of 2 and pi, and anything under the radical that's not a perfect square. These would all be irrational numbers. They're all in the number line, and they make up the real numbers. Now, another thing they're going to ask in use of these symbols, A is less than. The point is toward the lesser. The open end is toward the greater. So A is less than B. B is greater than A. And if we compare their position along the number line, anything to the right is greater than anything to the left. If you keep that in mind, that's a good little thing here. Now, a modification of these up here is if we add half of an equal sign. This is A is less than or equal to B. B is greater than or equal to A. Now, for this to be a true statement, just part of that needs to be true. And you'll be given examples of this. So 8 is less than 12 is true, because 8 is to the left of 12. Negative 6 is greater than negative 3 is false, because negative 6 is to the left of negative 3. So that's where it's a little tricky, and you need to be careful of the sign. Now, negative 2 is less than or equal to negative 2 is true, because part of it is true. And that's what we said. Okay. Now, when we graph this type of expression, where you have the x value in the center, there's a couple of important things going on here. And I'll give you some background for this. Now, you might recall that when you were in high school and you had something like this, well, there's a 1 right there. And let's say the 5 is right there. We used to say if 1 is not included in the set, we'd put like a circle around that, saying it's not included, and not included in the 5. And then we just put a line between the two. Now, in MATLAB, it's going to be hard to put a circle over something. But what you can do to indicate that is to put a parenthesis. So we have a parenthesis that takes the place of a circle. So that's what they have here. Now, I'm assuming that very shortly they're going to put an equal sign underneath this. And what would the difference be there? Well, now we're saying that 1 is included in the set, so we would fill that dot in, and we would fill that dot in. Now, how would you graph it, though? Well, we use, when it's equal to as well, we use a bracket rather than a parenthesis. So this is some of the skill, then, that you will need to know and be able to recognize when you do MATLAB. And this is introducing also what we call interval notation, which is a very important part. Now, interval notation can come right from the graph. If you look at the graph and you want to convert this to interval notation, what sign do you have here? Well, you have a bracket in the last one, and that you put a 1 there, indicating that 1 is included in the set. If it wasn't included, we would have put a parenthesis there. You put a comma, and it's going up to 5. And again, if it's not included, you'd put a parenthesis. But if it is included, you would put a bracket. So there's the graph of both of them, and there's interval notation. Now, if it's a piece of one and a piece of the other, then you would, be careful of these signs, and you'll get your practice as you do your lesson. And here in your textbook, they actually show you the inequality and then how it's written in interval notation. So because of its less than or equal to, greater than or equal to, a bracket on both sides. Less than or equal to, only less than, here you have a bracket, there's a parenthesis. And then parenthesis, bracket, parenthesis, parenthesis. Okay, they're giving us a nice little review here. And here they want you to graph the interval notation. So you're going to put a bracket at -2, and it goes on to positive infinity. Again, it's just indicating the arrow and the solid line. Okay? And in this one, it's coming from negative infinity. Now, infinity, by the way, always has just a parenthesis. And it goes up to 2. But because of the parenthesis, the 2 here is not included in the set. Okay, another little math definition is absolute value. The absolute value of any real number is its distance from 0. And since distance is always positive, any absolute value will always be its positive value. So the absolute value of 9 is 9. The absolute value of -9, again, it's how far it's from 0, is 9. Okay? So absolute signs are grouping symbols, and they are also an operation. Take the absolute value. One thing that's a little tricky is here we see we have the absolute value of a -9, which comes out as a 9, but then we apply that negative sign. So this ends up being -9. And again, they're asking you to follow the rules and then apply them to something. And your practice and later your quiz me will be your challenge. And in your textbook they give you some practice. So again, looking at what we see here, the absolute value of this, you're asked to do the computation inside the absolute value sign as if it were a grouping symbol. This gives you a -1. Now you do the operation. The absolute value of -1 is 1. Okay, now all of your exercises that they do give in the textbook in the old days will be done on MathLab. Again, we strongly urge that you keep good records, taking notes, and recording your results. Any problems that you have, indicate by using a highlighter or a star or something to bring into MathLab, where the tutors and instructor will help you resolve your problem. Okay, this will wrap up our first lesson in Math 1108 using the textbook.